Hi, Ken. Welcome back to the Real Talk.
Hello, Rob.
Thanks for
Nice to
coming
see you
back.
again.
Yeah, thanks for coming back again. And now jumping on another subject of the anti-counterfeiting and how Rochester is mitigating and supporting the anti-counterfeiting and spreading their awareness and knowledge to the OEMs and EMS companies around the world.
Yeah, thanks. Yeah, we've been front and center of anti-counterfeiting efforts on both sides of the Atlantic for the last 40 years. It's been around that long. Counterfeit products have been out there for time immemorial.
Yeah, it's a big topic. I know starting in probably the late 90s, 2000s, when Asia or China came online, a lot of the started. I mean, counterfeit's been around many years, but into the electronic semiconductor component level, it's quantified year over year, and it's gotten to the point where it's caused a lot of massive disruption into the supply chain because of the gray market out there, and a lot of companies are. So what are the share some of the stories that you've seen and what is happening right now to in the marketplace and counterfeiting? How do you see the past, present, future? Is it getting greater, or is it getting reduction because of the such restrictions now of the supply chain, or what do you see going on?
Well, counterfeit risk really peaks when there are two things in play. The first is where demand outstrips supply. The market that we're in at the moment is a prime point at which counterfeits flood in because of the premiums and the desperation that's out there at a customer level. At the second is really for obsolete product. And when a product goes end of life, we talked about forecast changing, circumstances changing. You don't necessarily always buy all the components you need. Markets often change after the point at which you've made that commitment. So there's an ongoing need for obsolete components in industries like the military, industrial, transport, energy. Those people need products for 20, 30 years. And semiconductor life cycles are significantly less than that. What fills the gap? What do people assume is their only option when it comes to obsolete components? Grey market, unauthorized sources, whichever you want, whatever you want to call them. But basically people who will source the products from a variety of sources for you. Now, people probably not aware that there are alternatives to that, and I'll come on to onto how they might be able to reduce that risk with good planning.
Yeah, I mean that it's coming to our experience. That is one thing, is the planning and the counterfeit mitigation coming to certifications now, because I know supply chain's getting tighter with the certifications from, of course, people had basic AS now to AS guidelines, and there's the AS 8081s and the AS 6171s and the AS 5535. I think that's what it is. So a lot of these, especially in the aerospace and defense side of, they're much more stringent in the last, I would say, decade than they were the previous decade. And how, because of what you said, when obsolescence comes into the factor, there's a lot of components in the gray market, who they're buying from, the testing protocols they go through, and understanding, how to identify counterfeits too. So that's one thing that I want to get to, is like, what are some of the issues with education that Rochester does to help the customer on that?
Yeah, so there are lots of AS standards out there, and they provide a cover, if you want, for the legitimizing the purchase of grey market or unauthorized product. These are inspections of various kinds and best practice to try and make sure you minimize that risk. There is really only one way to absolutely guarantee no counterfeits in your supply chain, and that is buying from an authorized source. Now, everybody knows that, and that is probably the way that they purchase for their production. However, the rules seem to go out of the window when a product component goes obsolete, and they assume then that there is no other alternative but the brokers or the grey market. There are alternatives, and the authorized sources, the aftermarket people, are there to provide that 100% guarantee even after formal end of life.
Yeah, and so in that matter, if I know Rochester has a lot of the services to help on the authorized, from the obsolescence, carrying old product, legacy products to help mitigate that risk. But when it goes into the side of like on the AS standards and what they do is, if there's obsolescence, if there's something out there for a legacy product, is testing enough to determine the quality?
Look, counterfeiters are really good at their job. If someone wants to deceive, paperwork, qualifications can be forged, as well as the product on the outside, the marking and the original source. All of those things can be hidden, and the days of poorly printed logos and manufacturers' names being misspelt, look, those are the easy ones to pick up. Basic inspection can pick that up. What we're talking about here is product that has been recycled, sold as legitimately new, when in fact it's already had a life in another piece of equipment somewhere. All the stresses and strains that it's had in being pulled off a board it didn't want to come off, all the chemicals that have been used in order to get it to look like it's new. All of those elements really are very difficult sometimes to identify. Basic AS testing for anti-counterfeiting, anti-counterfeit practice gives you some elements and should protect you from the most basic of counterfeit products. However, I would argue that there is an awful lot more risk in the ones that look legitimate and that are everything you would expect them to be, but on the inside there are other things going on. So there's plenty of those around.
Yeah, I mean, I think we've all had firsthand experience of watching or seeing these products that look spectacular. Oh, this is, and then really getting into it, you see that this is not, doing those AS basic testings of the X-ray decaps, even doing RoHS testing, seeing that this part is not, it's supposed to be RoHS free, supposed to be lead free, but it actually has lead in it. Well, this doesn't make sense. These are the types of things you get into it. But at the end of the day, it's like, how do you mitigate that to be 99%? And I mean, some of the things that we've run into, our experience is also, it's like doing a testing of full board, putting it on a board, especially doing a board test and doing having a golden sample of a real legitimate through authorized, if that comes to the point of how do you get there. And a lot of these customers, I know, as you say, come to you, we bought this part from X, we bought this part from this supplier Y. They gave us some test reports where they said they were legitimate, and then you're like, well, we ran the trace codes and these don't even match. These are a lot of things where people get into the trace codes, what goes to the labels, running the barcodes in general. Those are cosmetic, but
yes,
the actual electronic side.
That's the word exactly. These are cosmetic tests. That's the maximum really that any broker or unauthorized or even many of the third-party test houses can offer you. Yeah. They can never match the original test setups from the original manufacturers. They don't have the connections, they don't have the original test programs. So whatever they put in place, even if there's some basic functional testing there, is a very, very poor relation to what the original manufacturer put in place. And are they going to do it at the extended temperatures that you're after? Are they going to do full functional testing at minus 55 or 125? Those elements, really, the only guarantee that you can get is where you have authorized product, and you maybe also have a manufacturer, a post discontinuation manufacturer, someone like Rochester, who gets the original test programs and can offer you that guarantee. Those are That's really the only substitute really here to make sure that you have a risk-free life.
Does the question probably some people listen? Does Rochester have testing services?
Yeah, you know, we have relationships going back 40 years with some of our earliest manufacturers. When a product is made end of life, we negotiate with those manufacturers in order to get all their finished product, the surplus at end of life, but also their wafer, their test IP, their assembly IP, and everything we need in order to be able to legitimize our future manufacturing. They transfer to us test programs that have taken 200 man years to put in place. There is no way that a third party starting from scratch would be able to come even a fraction of the way there. And you often see suppliers and third party test houses saying the product's tested. Exactly what level is it being tested to? Has everything on the memory, every memory location being tested? With a microprocessor, if you look at the data sheet, the data sheet is only a small portion of what the original manufacturer would otherwise test to. We have the full package behind the scenes, and therefore it allows you the confidence to be able to go forward without requalification when you get a product manufactured by Rochester. So yes, the relationships are that strong and that embedded. They trust us. Their relationship, their reputation is tied to Rochester. They legitimize us, they authorize us, and that means they're happy that their products are built by us to the same standard. If there was any doubt at all, if there was any holes in this story, they wouldn't allow us to do it.
Yeah, you answered my question in that was, does the spec sheet or data sheet have the testing protocols? And just so you answered, no, it doesn't have it. Maybe he'll show half of it. The other half, it's IP that they don't disclose.
Yes.
Which does could contradict if you send it to a test house. There could be functional issues, and the bank. There is a lot of parameters you brought up: heat, putting in chambers, hot, cold. What's the dissipation of it? What is the tolerance changes of some from the passive side, or the actives of can it withstand those type of environments over a certain period of time? But yeah, you hit a lot of those points. And for another question, I think maybe some people are answering: can somebody that has a component or bought it and doesn't, or a customer or OEM that doesn't know where it came from, can they send it to Rochester for them to test the part?
We don't do that, and we're prepared to help our key customers, but we are not there to legitimize unauthorized sources, and stop. We've often done it in the past in order to find out why a particular customer was having problems, and some of the stories that we've got would make your hair go white, but we don't do that as a service to the market in general. Authorized.
Yeah, I mean, I just said that you tested the failure analysis, doing a failure analysis of why it failed and giving that as a service to customers. Like, this component is not legitimate, or this is the failure point, and doing that as one of probably some of your key customers, because sometimes they run because they bought from somewhere else and they come to Rochester. Can you help us? Can you do a failure analysis? Can you show us, is this legitimate?
Well, we've had, I'll give you one instance here where everybody followed the AS rules. Our product was part of a comms system for the French military. It was in every surface ship, every man pack. It was a key component in every one of their comms platforms. And one of the manufacturer's components went end of life in 2002. They continued to build those products for another 10 years afterwards and sourced their products. Brought them in, did the full inspection, plugged them into boards. They all worked perfectly. And, they did everything right according to the AS rules that they were able to to adhere to. But what they didn't know, what they found out slowly was that they were getting an increasing failure rate from their platforms in the field. And as they were bringing these back, it was this one component that was failing. Now, they'd sourced from what they thought was a legitimate area. They'd done some inspection when they came in. What they looked at under X-ray, everything looked fine. They then did a scanning electron microscope analysis of the product, and they identified what they thought looked like corrosion on some of the pads, and some of the bond wires were broken. Now, this couldn't have been the case when they originally plugged it in and tested it, because it passed at the time. But a number of years after, these products were failing in increasing quantities. Basically, it was compromising their systems in many different locations. What they did once they decapped it and they did an analysis of the materials that they found in there, was that there was a chlorine compound that had entered the product at some point in its past. Now, chlorine has no place at all in anywhere near a semiconductor. It should never be anywhere near a line, but somehow or another it had entered here. And what they eventually worked out was that this product had been recovered from boards in the Far East, had been cleaned up and fully refurbished. But in pulling the product from the board and cleaning it, those cleaning agents had slowly entered and migrated through the product to eventually eat away the pads and the bond wires, to the extent that they eventually had to do a full recall and rework on every comms platform that they had. I mean, a major incident, but something that they feel that they did all the right things for and still got hit. You know, it just shows how difficult it is to identify a product that is claims to be something that it's not. It happens all over the place. There's nothing really that surprises us anymore about how good these things are when they come in. So.
Yeah, I mean, I was assuming when you were telling that story, I'm like, well, was it a commercial product that they sold for as military high rel? But no, actually, it's amazing how sophisticated they are, and how sophisticated these people for they recycling the chips, how the systems are, and how they can get down into a quad flat pack component, resurface it, repackage it, make it look brand new. It functions, but just like you said, there, unless you really got down to the material composition and looked at it, get to a microanalysis of us, those type of machines and equipment, usually, and even in an AS6081 doesn't do it. You need to really get down to high, I mean, I guess maybe some of the AS55, 35, some of the other ones, but they're very expensive. So not everybody's going to go through these. People don't realize you can get down to testing, but the cost weighs out sometimes the point of even going, just go through, as you say, authorized channel, then to the risk, because one component can cost you thousands of dollars to test it, but it's only worth $1,000. Cost you 10,000, but the whole thing is worth $1,000. Is it worth that? These are, as I said, not testing could happen, but doing a sample testing does not do it. So there's a lot of parameters and know-hows, but at the end of the day, just like you said, is just find the traceable products that is from authorized channel or it's derived and surprised from. That's your safest bet possible instead of trying to mitigate a disruption.
We've had examples where the original manufacturer has spent ages trying to work out whether this product is legitimate or not, because it was so good in terms of its the counterfeiting on it. In the end, the only thing that they could they managed to work out was that the ceramic packs themselves were being milled. The top of them were being milled off and then reprinted. Otherwise, there was no way that they could work out why this product was failing, that it wasn't doing what it said it would do, etc. And I mean, it's a really, really pernicious part of our business, unfortunately. So yeah, but we've been fighting the good fight, trying to highlight the risks involved in counterfeit. We're part of a couple of forums, the IOM, which is a group in the UK, in North America. We're members of those groups, basically trying to highlight the risks and also to preach good practice when it comes to sourcing of products. We sometimes feel like we are always the doom mongers, but planning for the worst case and assuming the worst, I think, is probably the easiest way to put it. And the groups there have broad forums of customers from all sorts of different markets. It's not only military, but the transport and energy and medical groups are all facing the same sort of issues at the moment.
Yeah, I mean, I would say thank you for all that input, because of course we are part of the AS family. We're AS and all, but the information that we get updated from the GIDEP and from the SAE and all these associations that work on this type of supply chain mitigation, anti-counterfeit, it's like yourself, like the wisdom that comes. This information is key for all companies, from manufacturer, distribution. Everybody goes into it, because I mean, there's stories I've heard that there's parts franchise got hit with counterfeits because it was recycled back in. It was a return RMA parts that got back into the system, or these things. I mean, it's gone, but I think everybody's learned that, okay, do not, these are things that I've talked to some distributors. I won't say the names, but it's happened. They're like, how did this get in a supply chain? Came through a return somehow. It came through a return.
Yes, and now in the market we're in at the moment, with desperate customers out there facing a halt in production for weeks and months ahead, the decisions that they're taking will have an impact on the quality of the products they eventually put out. Because if they choose to go down those routes in order to satisfy a production call, there could end up with some serious issues beyond it. So yes, now is a very dangerous time.
Yeah, it is. Well, thank you, Ken. Thank you, Ken, for all this experience, wisdom, all the information for like I said, anti-counterfeiting. Just as I said, in this time, it's the most critical point. When we have a disruption, we have lead time allocation, 30 to 40 weeks. Companies are running and scrambling, trying to find components off any shelf or under any rock. To keep that production, fill that gap. And these are the biggest times where we can have that type of counterfeit or that disruption of production and failures that can happen because of these type of decisions made by customers.
Yes. Anyway, it was good talking to you, Rob. Thank you very much for the opportunity.
Thank you very much, Ken. Take care. I'll talk to you soon.
See you.